Good morning, good evening, good afternoon, everyone. Welcome in Salesforce FX Hour. My name is Amit Chaudhary. I'm your host, and today we are going to talk about Apex best practices in 2022. And we have a great speaker, Mohit Srivastava. He don't need any introduction. He's well-known personality. So let me hand over to him for his introduction and the presentation. Hand over to you, Mohit.
Yeah, thank you, Amit, for kind introduction. Hey, everyone. My name is Mohit Srivastava. I'm a lead developer advocate at Salesforce. You can actually follow me at my Twitter handle at msrivastu13 if you have any feedback about this session or anything in general related to Salesforce development. So today we're going to talk about best practices with Apex in 2022. Okay. Now, before I kind of begin, there's a forward-looking statement here. So that means, please do not make any purchasing decisions based on anything forward-looking that I might make in this, in this talk. I'm not going to make any, too much forward-looking statement here, but in case, if I end up sort of speaking something, just be mindful of it. Okay, so let's talk about what are some of the agenda topics that we'll cover today. So I'll cover what is Apex and its significance. And one thing I want to level set up is this this whole presentation is for advanced Apex developers. So if you are like looking for an intro level content for Apex, there's already a lot of Trailhead modules on Trailhead, and I would recommend them to get started with it, or look at Apex recipes sample app and Apex documentation to get started with it. This is more of an advanced content, so it assumes that you have already been sort of building Apex, at least you have like a couple of years of building Apex. And this talk is basically to help you go to that next level of, okay, what are the things that I need to consider when I'm writing Apex, so that my code is adhering to the best practices. So we'll look at some of the security best practices, how we can optimize performance of your Apex code, how to design an Apex code for scale. That means, it should work with large data volumes. And it should take advantage of all the possible governor limits that are around built around it. So how to like sort of write best possible code, and then how to write reusable code. That's is very important aspect, like dry principles, like do not repeat yourself. So I'll show some of the ways of how you can like write reusable logic, and then finally we'll also sort of understand how to write a maintainable code. That means, it should be sort of maintained even in the future. Let's say it's durable, even after 3 years, your code is working fine, and there's less maintenance. And even if there is a maintenance, it makes it very easier to hand off to, a support engineer or someone sort of supporting your Apex solutions. So how to like, make sure that you write with right with that mindset. And then I'll share some references for you so that you can get access to some of the resources that you might find helpful in sort of understanding this. Okay, with that being said, let's actually look at what is Apex, right? So first, what is Apex and its significance? Apex is designed, it's a programming language developed by Salesforce, and it is designed to automate complex processes. So, you might have complex business rules and logic, and let's say on an insert of a record, you want to sort of take care of those logic, or you want to automate that so that not for every business process the user has to go to the UI and take actions, right? So this is what Apex is all about. It's all about automation. So any logic that you can think of in Salesforce world, you can either write it in Flows today or Apex. Flows has limited capabilities. The capabilities are getting enhanced, but the good news is Apex is more powerful, and both Flows and Apex can work together as well. Also, feel free to use chat to answer questions. I'll get onto it, in between this, so that you get all of your questions answered as well here. Also note that one of the core difference of Apex compared to other languages that you might be used to, like Java or .NET or Python or anything like that, is, those languages are typically sort of run on its own. That means, you can deploy them on a server, you can bring your own tools, you can use open source libraries, all of it good stuff, right? Apex is also very, very similar to that, except Apex is multi-tenant. That means, Apex runs on a shared environment. So that's why we have like governor limits around it. And you need to understand these governor limits and work within those limits. Also, the one good thing about Apex is it's actually easier compared to other languages because it is opinionated. And the other thing is with Apex is you will see that we have a limited set of like kind of libraries in Apex. That means uh, you know, unlike Java, where you have like different types of hash maps and tree maps and other data types, Apex is pretty strict in that, like it has specific data types, it has specific methods, it is sort of optimized library. And you'll see that the tools that are required to start and build Apex is very simple compared to Java. You don't have to set up like JDK. You don't have to, sort of have a lot of tooling in place to get things going. You just need an IDE, and then you're straight away deploying to Salesforce. And in terms of like dependency management, you're not like sort of having to maintain like pom.xml or a Maven or something like that. Unlike Java, you don't really need to, because it's just the way you write a program in Apex is it's pretty tightly coupled. That means you have access to database. There's already Salesforce has a data persistence layer, it's database, right? So Apex directly has access to it. So you're not starting server or stopping server or managing that aspect of it. It's straightforward, a language designed to write your business logic. And finally, I want to say that Apex is most sought out skill. So today in the developer market ecosystem, right, it is one of those skills that is definitely valued, and sort of the Apex engineers are most sought people, and they are paid well. So just want to maintain, say that. All right, with that being said, again, as I said, level setting again, this is going to be a talk where we will sort of get into the habits of like advanced Apex development, right? It's not for like beginners. So this is like an advanced content. So the first thing that I want to start today is security best practices of Apex code. And this is very important, because if you're writing an application for an app exchange, let's say, if you do not have Apex code and if you do not follow security best practices, you won't be able to sort of publish those apps on App Store. Um, so that's the challenge with not following the security best practices. You might not be able to get your code to the production. It's as simple as that. It's going to be a big blocker if you're writing an app exchange app and if you do not follow the security best practices. Similarly, if you're like working for a consulting partner, what happens is if you do not follow some of these best practices, let's say your code gets audited by some third party vendor or someone, they might raise flags around that you have not taken care of security. And also sometimes it's not good from a data accessibility perspective. That means what happens is, let's say, if your admins have configured things like object security, feed level security, data access via the row level security, all those things you will have to consider in your code. Otherwise, whatever the configurations that they have made is not going to be any more applicable, and your user get access to more data. So how do we enforce security, right? So the key concept here to understand is Apex always runs in system mode today. So if you write an Apex class today, it always runs in system mode. That means it has all the permissions. Like within your code, you can even get access to the data that the administrators might have restricted, right? So one way to control access to like row level sharing of the data. Now there are two different things that you need to understand: row level sharing and the object and the field level security. So these two are two different things. In fact, in most of the Salesforce interviews, you will be asked, like, explain what is, sort of sharing, and what is object and field level security. It's very common question, right? So sharing is row level. Think of it as sharing as row level. So when you have rows of data, you want to control which data is accessed by which user. That's called row level sharing. And in Salesforce, there are like 18 to 20 ways to share records. So initially it starts with like setting up an org-wide default where you lock the records, and then you slowly open up access to those records by writing sharing rules, right? Um, and Object level security is like accessibility to your columns or your metadata, right? Like, let's say you want access to the data, but in that data, maybe one column of that data you don't want to show. That's where the field level security comes in, right? And object is for the whole object, what do you want to do with it. So those are already set by administrators. So in Apex, the way you can control the sharing of data rows, or make sure that those sharing rule applies, is by using a keyword called with sharing. So when you write a class, right, like I can show you a class, you typically write like public with sharing. So when you write with sharing, what happens is all the sharing rules are respected. So that's the key thing, or the base thing, is it starts with like a system mode by default. Then you have to use either with the sharing, without sharing, or inherited sharing. So when you say with sharing, that means all the sharing rules apply. Without sharing, you'll skip all the sharing rules that are configured by the administrators. And then finally, inherited sharing means it depends kind of thing. So when you put inherited sharing, what happens is, let's say your code is getting called from a trigger, then it runs without sharing mode. Okay. Now, if your code is getting called by, let's say, a lightning component, right? In that case, it's going to be like without sharing, right? So it depends on the context. Now, if you don't put like, if you put inherited sharing, the other advantage is it depends on the code that is calling this specific class. Let's say you have a class with inherited sharing and you have another class without sharing. And if that without sharing class calls this inherited sharing class, what happens is this inherited sharing class runs in and without sharing mode. So it is like with inherited sharing, you have more control. Primarily useful when you are sort of building like some sort of a library, because then you want the implementer to sort of take care of, without sharing. So this is about with sharing and without sharing. That I said, that's the row level access for the data. What happens for, the column access, right? Like, for example, name field here, or when you are doing an operations with an object, let's say I'm inserting an account. So for that, we have a beta feature called user mode data operations, which allows Apex to run in user mode. So this is a beta feature that lately came in 2022. And what this allows you to do is, let's say you're writing a query. If you say with user mode, what will happen is this whole query will run in the user mode. It will not run in the system mode. That means if the user doesn't have access to the name field, what happens here is they will see an error saying, hey, the user doesn't have access to the name field, right? And they'll not see the data, basically. Similarly, when they're inserting rows of objects of data here, you can say insert as user. So previously you used to say insert ACC. Now you just add as user. That means this whole operation now runs in user mode. That means it respects the CRUD and the FLS. That CRUD here is create, read, undelete, and delete. Right? Sorry, create, read, update, and delete. And FLS is field level security. So here, if user doesn't have access to the name field, we are trying to insert that, the code will just throw an error saying, hey, you don't have access to the name field. You're not supposed to insert it. So that's the idea behind us, to make sure to use sharing keywords, understand what is user mode and system mode in Apex, and then make sure all your SOQL that you're writing, all your DML that you're writing, take care of CRUD and FLS permissions. Let's look at some of the questions in the chat here. So is the user mode similar to security enforced in SOQL? That's a very, very good question, and a very common question that I get asked. So for those of you not familiar, a SOQL also have something called as security enforced. So if you, let's look at security enforced, right? So if I actually look at the let's me open a new browser here. So if we actually go look for with security enforced SOQL, we will see it's almost same thing. Like when you use with security, it makes sure that the field level security are respected for all these things. Just give me a sec. So what's the difference between this security enforced and this new feature that came out, which is user mode database operations? Salesforce. In beta. This one. What's the difference between those two type of queries? Right? This is what or summer 21. Maybe that is summer 22 is the latest one. I just don't want to use the older release notes here. So let's switch on to the. All right, so in the Apex, we introduced user mode data operations, right? So when you write a query, right, you can say with user mode or with system mode in your SOQL, right? So previously we had this thing, right, with security enforced. Now with security enforced has so many limitations. So one of the core limitations of with security enforced is, um, it does not support lots of different types of queries. That's like the number one thing, right? It does not support lots of different types of queries. Like, for example, if you had a SOSL, right? If you had a SOSL, that thing is not actually supported in the user mode. Or sorry, if you write an SOSL with security enforced, first of all, I don't know if you can really write an SOSL with security enforced, but even if you do, it's not going to work, right? Similarly, like if you have a polymorphic fields, it'll not work. Also, there are certain fields that are exempted. Also, in terms of like performance, right? In terms of performance, you will see that the new one is a lot better. Okay, so those are like the core features. Basically more performant. The new one is more performant. It supports SOSL. Okay, that's like the newest thing. It supports SOSL, and then it's substantially better, like in terms of the code. It's clean, right? You know that it's with user mode. It's better than writing with security enforced, kind of. Yeah. Yeah, so the other key difference that I want to mention here is with user mode is it always applies the row level sharing. That means if you put with user mode in your query, if the user doesn't have access to the data, even if the class is not using with sharing, right? If your class is not using with sharing, it's still gonna be fine. Like it's still gonna respect or filter out only records that you can see. Hopefully that answers your question. Um, that's for Nico Warley. So Nico, hopefully, does it throw an exception or just omit the name data? I believe at this point you can like configure that behavior. I'll have to check this out actually to see whether it actually yeah, I think it actually throws an exception at this point, but I believe there must be some kind of a flag that um, to control that behavior, or at least you can try and catch them at this point for sure. You can try and catch it. But you're right, like what happens if you really want to run them? So try and let us know, Nicole. I'll also try myself. All right, so moving on to the next best practice. Let's see if we have any other queries. Still folks are joining here. Let's see. Can we use system.run as function? No, so the system.run as function is only for the test classes. So no, on your actual code, you cannot use system.run as. So Amit says by using with security, we can enforce the field level. Yeah, exactly. And if yeah, exactly. Exception is thrown and no data is returned. Exactly. That's the security enforced. Yeah. All right. So next best practice, right? So this is like the thing, and you can use like Apex PMD in your IDE, right? To actually discover some of these as you're typing your code. Make sure to use Apex PMD so that you don't miss out. Because I know, as an Apex developer, one of our habits is like once you get into habit of like just writing code, without considering all of these, it takes time to get out of that habit, and Apex PMD can help you with that. All right. Why state without sharing in the class if system mode is default? Oh, that's a good question. Actually, sometimes even without sharing, there are places in Salesforce that you will see that sharing will apply, even though like it should not. So without sharing is more for like explicit way of doing it. Like you say, okay, this class has to run without sharing. Okay. And the other thing that you need to understand is if you don't put without sharing or with sharing, the caller class controls the sharing of this specific class. So if you have a without sharing class, if it calls this class, even if you want to run this class like in with sharing mode at that point, or let's say there's a with sharing that's calling this class, right? So the caller class controls the thing with it. So if you are very explicit about running this class without sharing mode, right, you should always specify without sharing and not leave just as it is, because then the caller class will control its access. If you want to explicitly say it's without sharing, just put without sharing, so that even if the class that is calling is with sharing, it will still make sure that this class is running without sharing. Okay. All right. So next, moving on, the other security best practice, and this is for more for folks who are working in like privacy or regulatory industry, is to make sure that your Apex code has access to all the data. So if you have to really respect privacy and regulatory compliance for, let's say, our data showing on a Lightning Web component, right? You're eventually using Apex for that. You're showing some data with Visual Force, whatever. Like if you have used Apex for that, you have to make sure that it's compliant. Or let's say you're doing an outbound integration where you are calling a third-party API, right? Even in those scenarios, right? You're sending the data over HTTPS network, which usually is secure. But let's say you have a very strict requirement, right, around security that no, it still has to like, or even over the HTTPS, it has to be encrypted. So for that, note that Salesforce has this feature of encryption, shield encryption that you can enable, and that will make sure that your data, when it sits in the Salesforce database, that is data at rest, that's what it means. Like when the data sits in the database, it's still in the encrypted format. And also when you're using Apex, there are different encryption techniques that Apex support. So all of that is there in the encryption recipes here. So for example, if you actually go to Apex recipes app, how many of you know about Apex recipes app? So if you actually go in Google and search for Apex recipes, you will actually come across a repo. And this repo has all the code that you need, like all the sample code to get started with, like not get started, but to become an advanced, sort of a developer with advanced concepts. So one of the recipes that we give is encryption recipes. So go look at encryption recipes class. We show you how to sort of use different cryptography encryption techniques. And this might be something really useful if you're in a regulated industry. So anytime you're trying to like save data, or let's say, do an outbound integration with Apex, you should be able to use one of these encryption recipes to sort of encrypt data. So for example, if you see here, I have a hashed data, like I have this test data. If I want to hash this data, I'm hashing it out with a SHA 512 hash algorithm. So I just put the data to hash, and also so I generate a hash key first with the data to hash, right? And also the data, and then I can encrypt this data, or in this case, it's just checking up whether the hash was established. So hashing means it's kind of encryption technique, right? So there are different encryption techniques here. If you want to do, like, for example, AES algorithm or RSA, based on whatever your requirement is around encryption, right? We show you how to work with that, okay? Or if you're doing some kind of an integration which has this requirements of encryption, decryption, then make sure to use it. All right, so the next thing that I want to talk about, so these were all the security best practices, right? Finally, when you are doing integration, one of the best practices to always use named credential. Okay, so Salesforce has this named credential. So this way you are avoiding having to store username and password. So that's very important. So that's one of the security best practices. This is not a security best practice. It's just a general best practice, is to understand the limits of Apex for integration. So sometimes what happens is, like, you overuse Apex. Like, for example, Apex has all these limits. So make sure you understand that, because most of the times what happens is, when you're trying to integrate other third-party systems, there might be a better way to do it. Not just use Apex. There might be a way to bring middleware which might have more capabilities. There might be other integration patterns that you can use to sort of run your integrations. Let's see. Yeah, thanks, Barbara. Next question is connected app, name, credential, remote site difference, please. Somebody's asking connected app, name, credential, remote site. Yeah, so the thing about connected apps is when you want to integrate Salesforce to an external system. That means an external system wants to talk to Salesforce, from their server. Let's say there's an app written in Java and it wants to, like, communicate with Salesforce. That time you create a connected app in Salesforce. So Salesforce will give you a consumer key and the secrets, so that the other app can actually call to Salesforce with that keys. So you share this connected app keys with that other application, so that the other application can actually call into Salesforce. So that's connected app. And remote site settings are, let's say you are reaching out to an external website or an external site or an external application that has an endpoint from Apex. So by default, Apex will not allow you to simply make a call. Okay, you have to configure in your org saying, okay, I have whitelisted this specific endpoint so that my Salesforce Apex class can actually call into. Okay, so that is remote site setting. And named credential is, so remote site setting is, think about anything in general, like it need not have authentication or authorization. Even if you're calling to Google from Salesforce, like Google website, without like providing any username or password, you still need to use like remote site settings you still need to declare that remote site setting. But named credential is beyond that. It has this authentication protocol. So what you're doing is, it supports all these authentication protocols that are shown here, right? So it makes very easy so that you don't have to handle these protocols, or you don't have to code for these protocols. Now, one key consideration is, if you use name credential, you don't need to specify a remote site setting. It's already taken care when you specify the token endpoint you are. I hope that clarifies the question. Okay. Now let's move on. So the next thing I want to mention about security, the very common, is SOQL injection attacks. Now, SOQL injection attack is pretty severe if you are like running a SQL statement within, like, let's say a Java app or a Node app and things like that. On Salesforce, it's not that a bigger deal, honestly, but you should still know what it is. So to help you understand, right? So let's take this query, right? So what this query is doing, it's selecting ID from contact, where it's saying, okay, the contact should not be deleted. Is deleted equals false means, it's not in the recycle bin. And its name is like name parameter that comes from, let's say, a Visualforce page or a Lightning Web component. So you construct this query and you query the record, and then you delete the record. Okay. So now imagine what happens if this name parameter was supplied with this string, like test, ampersand dash this or this. So this was actually so for example, this one, right? Let me highlight in blue. This one, right? Let me bold it out. Bold, and let me increase its font. Okay. So this is what the user supplied. This thing was supplied to this name variable. Now what happened because of that? Your final query became something like this. So ideally what you wanted is, let's say let's say Mohit, I want to query and contact with name Mohit and delete it. But now instead of Mohit, this hacker sent this weird string. Now this query automatically transformed to something really interesting. So it's querying now all the contacts with name test. Or got automatically added. So it's basically querying all the contacts now, instead of just querying that specific contact. And the hacker was just able to do it by just providing a string. Like he was a skilled hacker who know how the SOQL works. So he was able to like construct a query string directly to, instead of just deleting that one specific account, this code now it started querying for all the accounts in the system, and unintentionally it's just deleting it, right? So the hacker was able to access your contact table, was able to delete everything from that contact database, right? Or the contact object. So you don't want that to happen, right? So that's why you have to make sure that you use static queries. So if this query was static, the moment they send information like that, it will still go as name equals this, right? Or name like that, it won't be constructed like this. Or if you have escaped all the single codes, this codes would have just escaped, and this query would have sort of not been transformed to a query to sort of query everything from contact. Let's see if we have goodbye all contacts. Exactly. Yep. Goodbye all contacts. Yes. Perfect. Okay. So that's one of the best practices. Make sure that, and this again, PMD, use PMD with Apex. It'll tell you if you end up writing any dynamic SOQL. So these type of SOQLs are called dynamic SOQL. Okay. So if you end up writing any dynamic SOQL, what will happen is, your PMD will scribble those lines, and you will know that, oh no, this has to be taken care. So really what I would have done for this to what I would have done to just use instead of name, I would have done something like let's say something like name string, sanitized name. It's wrong here. Sanitized name, and then it would have been like see string something like this. Whatever your string is, name dot escape single quote. I think it's called string dot escape single quotes. And now you would have just put the actual name parameter here. And then this you would have directly used in the query here. Kind of, instead of using the name, you are using a sanitized name. That would have solved this issue. Right? Okay, cool. Yeah, just look at like escape single quotes method in the docs. You'll quickly understand um, what that does. So if you're writing an app exchange app, right, make sure to use this one. So you'll use string dot escape single quotes. Single quotes, this one. Okay. Make sure to use that in string to escape. I'll escape some of the characters here, and yeah. All right. Next. So these were all security best practices. Okay. Make sure to follow them in your Apex code. All right. Now let's talk about performance. This is a other aspect that as an Apex developer, you'll always have to think through. Yeah, string dot. Yeah, exactly. Okay, so performance best practices, right? So in the performance best practices, so one of the techniques that you can use to boost up your performance is by using a platform cache. So what is a platform cache? Let's say you're writing a query, okay, and you want to reuse that data from that query again and again, throughout your Apex transaction. So you can keep rewriting the query or like storing the query inside a map and then use it, right? Like you can have a singleton. I'm assuming everybody knows singleton here, but if you don't know, singleton is basically like a data structure that you create to hold a value throughout the transaction. So you'll create either a singleton, or let's say you requery the data, basically like have multiple sockets. So that technique will not scale well, because when you're storing a data, right, in a data in a variable, right, it has certain cost to it. And also if you're requerying it, you're using queries multiple number of times, right? So an effective technique that you can use is caching. So what cache allows you to do is you can put the data in an intermediate layer, right? So next time when you want to, like, you need that data, right? Let's assume that's a static data. You just query from that platform cache. You say, okay, instead of going to the database, let's just go to this cache table and query it, right? So platform cache can help you. And we have two different types of caches. One is like session or the user cache, right? And or cache. So you can store session, like, or the difference between session and the or caches. The session is only for that specific user. So let's say in that specific session of the user, right, you have some data that you want to like just cache it and use that, then yes, session cache is the way to go about it. But then, there might be a way, there might be techniques where you're like, okay, this has to be cached for this entire app. Like, this data, I just want to cache it one time and then, sort of refresh it later on. But let's say there's too many concurrent operations that are happening, then I can use R cache. So in the R cache, I'll store the data. And then every time I don't have to go to the database, I'll just use R cache. Now, to show you an example of that, take a look at platform cache recipes in the Apex recipes. So see how the platform cache recipes are actually built. So basically, we have this specific class called, let's see, let me show you. So we have a class called, it's all abstracted here. So, so this is for getting the cache value, right? There should be a setting or store the value. Yeah, store. Okay, so this one, store. Yeah. So basically what you do is you have something called as partition. So you get that partition and then you use the key and the value to store it and the time for which this cache has to happen. So you just say partition.org, which means it's org type cache. Get default partition basically is a method that somebody abstracted, which says cache.org. So cache.org is the namespace, right? So from cache.org, you are getting a partition, right, by name of the partition. And then you can retrieve the data, or you can use the put method to put the data. So, we have abstracted, like, for example, if you already had this platform cache recipes class in your org, all that you need to do is say, If you want to cache our data in the OR cache, you will say platform cache recipes dot store value in OR cache. Let's say the key value for that is account, and this is the data that you want to cache, right? Similarly, to retrieve data from an OR cache, you could do get default partition. You can call that method, it's of which type, arc type, and you can say dot get, and account is the key that you want to get the cache values out of. So imagine like a very expensive operation where you are doing a complex calculation, okay? And that complex calculation, you want to persist throughout the session of the user. Now you could do that and put the value in the cache, and then next time your app needs it, it'll just go retrieve from the cache, for that whole session of the user, right? Most of the time it applies good for static data, but if you have like requirements of, okay, the data should change, then it might not work. It's only for like static data, or your data is not frequently changing, or let's say, you want to do some calculations on fly, and maybe, it's okay to show the same calculations for like 30 minutes or so. So those type of things. Let's take some questions before I move on. Yeah, thanks for sharing the links to the Apex recipes, Nico. Yeah, so the Apex recipes is here. You can take a look at all of the code, as I said. Go look at for this specific example, go to the classes and go look at platform cache recipes example. So it's all abstracted for you. So you could use it, right? But if you want to like sort of really understand code, you can go to the cache R class. So just go to cache, just type this Apex, you will land up into the documentation, right? So I'll show you an example of how the R cache works and things like that. Yeah, how to retrieve and sort of use cache. Okay, cool. And note that for an ISVs, you can also separate the cache by namespace. So, and ISVs can separately have their own namespace to cache. So that's important. So if your Apex is actually suffering from performance, look for opportunities around that using cache. All right, the next technique that I want to talk about in terms of performance is using asynchronous triggers. So this one is pretty interesting. So, in Apex that a transaction has a CPU limit, right? So for example, let's say you have a trigger which inserts an account. That account has several triggers to go through. And as a part of that trigger, let's say it inserts some cases. And then all the processes that are on the cases, like workflow rules, validation rules, let's say you have a flow automation built using flow. There are a few more triggers on cases. So those all will run. And let's say that case also inserts, let's say case teams, another object. Again, all the process in that object has to run. So anything that you do touching database, right, via triggers or via, your LWC component or Visualforce component, or via like, let's say batch Apex or scheduled Apex, it goes into this transaction and it'll keep happening till all the transaction, like all the logic is completed for every object that you can find, right? So what happens in this process is Apex has this limit of 10 seconds. That's it. So if the transaction completes within 10 seconds, you're good. If it does not complete within 10 seconds, then you have a problem. That is, it's going to say CPU timeout. How many of you have had those? Feel free to use chat to tell you hit CPU limit, right? So that's called governor limit. And there are so many other governor limits. Like for example, you cannot have 100 SOQL statements in a transaction. You cannot have 200 EML statements in a transaction. You can only query for 50,000 rows in a transaction. You can only insert 10,000 rows in a transaction. So there are limits like that, right? There is also a heap limit, like number of heaps you can store for a data structure, right? So that's transaction. Basically, what happens when you do a DML or when you do an action inside Salesforce that triggers other processes, that in turn triggers other processes, and it goes on till an action is completed. That's called transaction, and you have a limit. So how do you break those limits? That's where the async triggers comes in. So with async triggers, what you do is, so you write a trigger on an object's change event. So every object in Salesforce will have something called as change event. Okay. When you say change event, so for example, account has an object called account change event. Contact has contact change event. So on a change event, what you can do is you can look for the change. So you can say, okay, get me all the records that have changed. And then I can compute that heavy computation in another class. Okay, so this way you are breaking up, or you can even like create a platform event from here and then listen for that platform event and then do your action, right? So you'll need a change data capture on account. It's basically a setting that you define in your org, and then you write an asynchronous trigger on that specific object. So with that, you will be able to decouple your process from that transaction to a different thread. Okay, so then what happens is you have broken that transaction. It's no more one like let's say you had like 5 different processes going on within that transaction. You have broken that transaction of 5 different things to, let's say, only 2 of them, and now other 3 of them is getting executed in different thread. Now let's say you want to further break that process of 3 into, let's say, 1 more process, and you can spin up a process from there, right? So that's one way to break the transaction. So this is another common technique that you can use by using asynchronous triggers and change data capture. This is called event-driven programming, where you're like listening for events rather than like sort of synchronously doing all the actions one by one or composing your actions one by one. So I hope this technique will make sense, right? So if you're running into Apex CPU problems, you should look for opportunities that can, where some things can be done asynchronously. Like for example, sharing. How many of you have like requirements around sharing rows, right? Like creating share records. That's a very common requirement where you can just create an asynchronous trigger and insert those share records in asynchronous mode. Because anyways, that sharing record, when you insert, there's an asynchronous operation that happens within Salesforce. So there's no point of like having that within the triggered transaction. Similarly, you have like, let's say, very complex logic, like multiple for loops, you need multiple, SOQL statements, etc. Then even in that scenarios, if that process is getting complex, you can certainly like use asynchronous triggers for that. Let's look at chat here. Are there any Trailhead modules on caching? Yes, there are. If you go to Trailhead and search for platform cache, yes, there are lots of Trail module. Yeah. All the time when I query for a contact in a 1 million rows. We'll come to that. That is a different problem. When I query for a contact in a 1 million row record, yeah, we'll come to that problem. It's a different problem. Is this a platform event? How do I pass the IDs to the account change event? As you can see here, very simple. If you have something called as change.change event handler .get record IDs, I'll tell you all the record IDs that have changed. This change object here has more things. If you actually look at it, will have which records got changed, whether the change happened because of the record updation, which fields actually got updated. All of that good information in this change object. Just go look at change data capture documentation and async triggers. You'll find more information there. All right, moving on. So those were performance best practices. Okay, these two are the performance best practices. Is make sure there's an opportunity for you to use platform cache. Make sure that you understand what is an asynchronous trigger and how you can use this event-driven thing to simplify or basically move your logic or break your transactions to multiple threads. Why are we looking? Oh, that seems like a. Where are we looking for cases? Oh, sorry, yeah. Yeah, that's a good catch. Somebody catched a good thing. Let's fix it. Yeah, sorry. So this has to be, this does not make sense. Let's say account IDs here. Yeah, good catch. Someone is like looking at the code line.
For the code loop, you executing on the case change event, not the account case event.
Was that?
Code loop.
Yeah, it has. And this one, yeah, exactly. So this one has to be here. And also there is one more change that I have to do is account IDs. Okay, great. That means everyone is paying attention. So great catch. Okay, yeah. So similarly, if you're doing on case, you will have a case change event. Okay, all right. All right, next step, design Apex code for scale. So till now, we have looked into performance, okay, and security. Next up, we'll look into scaling. So what does scale mean in Salesforce, right? First, let's understand what is scale. So scale means, so imagine today in your org, you had, an account object with maybe 10,000 accounts, right? You wrote a trigger, you tested it, it all works good, fine. 3 years later down the line, that 10,000 records grew up to 100,000. Now, if your code is not designed to work for that volume, then your code is not scalable. That means it actually broke, right? Your code actually broke. I was not able to scale when things got changed over the period of time. Okay. So now, first technique, when you want to scale in Salesforce, right? You want to write code that's scalable, is what we call as code bulkification. Okay, code bulkification is something that you should like really understand. So let's understand this with an example here. I have a simple for loop, right? You have simple account IDs. Let's imagine this set. This is a set. Let's make it very clear. Let's imagine this is a a set. This is a set of ID. Set is a data structure. I mean, set of account IDs is, let's imagine this is a new set, right? This has like whatever, whatever the IDs are, I'm just creating some IDs, but it'll be, something like 0x, whatever, Salesforce format, like 15 digit or 80 digit. So let's imagine this set of IDs, account IDs, is like there are 200 of them at this point, coming from some process. Some developer has written code like this. We don't blame that developer, it's just learning Salesforce, right? So we want to like help that developer a bit more to understand what happens. Maybe it came from some other background, coding background. It's totally fine to have something like this. So let's imagine this one is like 200 rows. It goes to like 200 data set, 200 elements. Now, every time, so what happens is for loop is first account ID will be picked up. It'll fetch all the contacts for that account ID. Next time, again, the same query for different account ID. Let's say account ID 2, 3, 4, 200 times the statement, the SOQL statement will be executed. And you'll get an error saying 100 SOQL limit exceeded, like this, in big writes like this, right? So because I told you, right, Salesforce has multi-tenant. There is a limit on number of SOQLs you can have within the transaction. And what have you done here? Like 200 rows of data, you have a query within a for loop. Okay, so this is not okay because this will not scale. Maybe it's scaled, when this account IDs were, maybe scared when somebody ran this trigger code by just clicking a record button or just editing. Let's imagine this code was within a trigger context. Let's imagine that this code was within a trigger context, and this set of account IDs was maybe one or two because somebody's just editing these records, and this code went through. So what happened in that process is only one record, so this was totally fine, it's all working fine, good. Somebody decided to data load, or let's say you had an external integration pumping data into Salesforce, and they are sending data in chunks of like 5,000 records. Now, platform has this capability of whenever you do more than 200, it breaks into batches of 200. So now this set all of a sudden became 200 records, and there are 200 SOQL that you already use, and your code is not working. So that's not good. So how do we simplify this, right? So in this case, you need a collection of all the contacts for a specific account, and then you also need to make sure that for you want to finally your code needs a data structure where, okay, I can easily say for this account these are my contacts. For account A I have 10 accounts. For account B I have 13 accounts. Account C I have 15 accounts. So you want some data structure like that, but you also don't want to write query within the follow. So how do we simplify that? By using our data structure called maps. So if you learn how to use maps that's the only complex data structure that we have in Apex. It's maps. So if you know maps well, you pretty much will code using maps every time, and you will see that it will actually you will be able to optimize this query so that it only runs one time. So let's take a deep look into this. So I created a data structure called map of ID, which is an account ID, and the list of contacts that goes along with it. So in your database structure, it will be like, okay, account ID 1, I have 5 different contacts, right? So how do you do that? So in the for loop, instead of like in the previous case where the query was within that for loop, I have an inline for loop. So an inline for loop is more efficient way to write a for loop. So I do an inline for loop. And then what I do is for every contact, so first I just query everything. Like I query all the contacts where the account ID is in this set, right? Similar to this, pretty much similar to this, except now I'm not querying by single account ID. I'm saying, okay, give me all the account ID, give me all the contacts for this bunch of account IDs by using this in statement. So this will give me all the contacts, right, that I need. But then now I need to sort by, or I need to organize, saying for this specific account, I need these specific contacts. These specific contacts belong to this account. This specific contact belongs to this, right? So in that situation, what I can do is I can use the map. Map has all these methods, which says I can say map.get, and I can look at if this map, the map collection that I have already has an account ID. If it does, then that contact actually needs to get added to that specific account ID or that specific collection. If that map did not had this contact or did not have this account ID before, that means, yeah, this is the first time that we are actually storing that contact for that specific account. So I'll create a list, I'll add everything to the list, and I'll put it into the map. So this way now, for all the records that are getting from my database, I'm able to sort of organize them based on, okay, for this account ID, these are my contacts. So this technique you will very often use, very often use these two slides actually, where this is one way to know SOQL or DML within the for loop. Similarly, I'll show one for DML. So basically ensure that anytime you're coding something, no for loop within within the method, or say, no SOQL within the for loop, or no DML within the for loop. That's like the key thing. So how about this, right? So this one, right? This looks like Okay, this method, right? So this is an account class that, let's say I created a class called account class, and the developer created a method to create an account like this. Now, where the developer is expecting someone to just pass the account name and they'll create account. Is this code like bulkified? No, because what will happen is if I call this code for 200, if I call this code within the for loop 200 times, it will fail. Why? Because when I'm calling this account.create account, test account plus I, you see this insert statement now all of a sudden went inside the for loop, right? So now you'll get an error saying 100 DML rows except, sort of exceeded. You can try this in your org. You'll see that. Just create a class like this. Just try to call it. So this code, although it looks, it looks to work fine, but in reality, it's not something that other developers can actually use because, even if they use, they'll have to use for one single record. And the moment they try to, sort of use for bulk records, this will fail. So how do we bulkify this code? So what I did there, what are the changes that I did? So instead of account, I started passing collections of account. So my method can now accept collections of account. The other thing I did is I created a collection for capturing all the accounts so that I can insert as a list, not as a single row. So as you can see here, what I'm doing here is I'm collecting all the account names that are coming, I'm creating a new instance, adding everything to the list and inserting as a list. Now, even if the developer sort of uses a for loop, they can keep adding to a set and then just pass that set to my class. And, my class is fine, it's doing fine. Unless the developer again goes and puts this class within a for loop here. Now, that's a no-no, right? But then I've at least provided a provision for the developer so that they can pass in collections. So they can create collections before and then pass everything as a collection instead of like single entity. And they can call this class just by passing collections. And then this will do everything as a single transaction. All right, let's take some questions here. Insert has a limit of 200, I think. DML, number of DML rows allowed. Is it 200? I think, yeah. I think it's 200. Yep, it is 200. That's fine. It'll fail for 201 records. All right. So what if one contact account has 200 contacts? Will that exceed limit? That's the question. It will not. If you look at this previous code, it will definitely not. This query can bring in 50,000 rows. But then that's why we have filtered by an account. So I'll talk about something, I'm getting to that. Like I'll talk about what are SKUs. When we look at what are SKUs and what is LDV, you will understand that why you need this account ID filter and why you shouldn't have more than 10,000 contact rows for a account. If you have more than, I would say if an account has more than even 5,000 contacts, you're getting into a problem somewhere in your Apex code. You won't be able to solve it. It's a data model issue that will happen. And, because of that, the Apex developer will never be able to write an efficient code. They'll have to either move everything asynchronously. It's a design, it's a design issue, but then it translates back into code. Okay, so let's see if I move on. Okay, it was confusing record complement. Okay, cool. All right. So the next thing that we want to talk about is large data volumes. This is like my favorite part, right? Large data, LDV means large data volumes. I was talking about, right? So always remember this rule, okay? Rule of thumb. How much of your code that you write, there is some boundaries. If you do mistakes in your data model design, It'll come down and bite you when you're writing code. So what are those things? So if a user in Salesforce owns more than 10,000 rows, it's called ownership skew, and it's going to cause problems. I'll tell you, may not, I mean, it might not look evident, or it might not be so obvious for Apex code, but it will internally, because there are sharing roles, there are things that happen under the hood, which involves transactions. And so let's explain this point bit, to explain what happens. So imagine a user had, a user is owning more than 10,000 records. Okay. Now, imagine a user has like 10,000 accounts. The ownership, you've assigned 10,000 record ownership to a user. Now, what happens is, let's say that user was part of an account territory, or let's say, account hierarchy or a role hierarchy. And for some reason, you want to move that thing, or you want to change their territory and things like that. So in that scenario, Salesforce at the back end has to process it. Like, it has to change all the records, visibility by querying all the records the user owned and then doing an insertion, which internally is again like 10,000 rows, right? There's this limit, within a transaction, like 10,000 rows limit, right? 10,000 number of rows you can insert. So somewhere, those limits will surface. So that's why we recommend no user owning more than 10,000 records, unless it's an integration user, kind of, who doesn't have like these sharing and visibility requirements and things like that. Oh, sure. And if you're using not Apex, let's say a middleware tool and a bulk API to insert, yes, makes sense. The other thing is optimizing is a parent record not having more than 10,000 child records. That's what I was saying. So let's come back to this code that we were doing, right? Sorry, did I go fast? Yeah, I'm going backwards here. So let's imagine this, right? In this case, in this example, imagine one of the account IDs already had like 10,000 rows. And let's say, you're updating these contacts. Let's say there's an update statement here somewhere. If one of these account IDs has more than 10,000 rows, and maybe there are two accounts, let's say the other one even has 500 rows, 500 contacts. So ultimately, you're trying to update like 10,500 records. So this logic will fail. I said, right, this is optimized code, etc., etc. It's gonna fail because you're not supposed to do more. I mean, there's no way you can do more than 10,000 rows of insertion in an Apex context. This is gonna fail. So that's why I said, if a parent record is having more than 10,000 child record, and if you're writing Apex code on that, your only way to get out of this is by using some kind of a Salesforce functions, or moving this to an external system like a middleware doing those updates. Your Apex just calling that middleware. The middleware picks up all those records and updates it. Even with that, you'll create row locks, etc. So don't try to do that, because you're locking all the parent, like child records, in the system that locks parent record. And if somebody is like trying to do an operation on that parent record, will create a problem, right? So that's something that you need to consider. Is okay, you need to be cognizant of this fact. The other thing is, when you're working with large data volumes, keep number of fields in the query to minimum. Only the information that you need. More the query, like more the fields you will add, more heap size you will need on the Apex. So always remember, don't just query because you have all the fields. Just don't put everything in the query. It'll cause problems for you. And then make use of the query optimizer. If you know what is query optimizer, if you don't know, like, unfortunately, I don't have time to explain it, but I'll give you a short intro for that. A query optimizer in Salesforce is like a tool that you can use to find out what will be the best query for this specific thing. So it will tell you, okay, if you like, let's say, order by or filter by. Somebody was asking like, hey, I'm writing a query on a million rows of contacts. Yes. So if you just write the query without using the query optimizer, what will happen is you will not know the consequence of that query and the query might fail. So there are ways like you can order by last modified date so that, it avoids to having to go through a full scan. So in Salesforce, what happens is we convert your SOQL into a SQL internally using the optimizer. With the help of optimizer, you can write a query where an efficient SQL is generated on Salesforce end. So try to look into that and see how you can do it. So I'll give you an example for a query which is inefficient. So look at this query. This is like most inefficient ways to write because you're including nulls. Whenever you check for like not null, the query performance goes pretty bad. And then if you have multiple conditions like this without like sort of optimizing it, right, it's gonna hurt your query performance. So the nice way to optimize is get rid of all the nulls. One way to do is like, for example, category, right? Here is not equal to null. You could assign a default value to all the null categories, and you could filter by default, not by null. Then that improves your query performance, right? And then optimizing the filtering, as I said, like, instead of having all these and conditions like this, there might be a way to find out a more efficient query. If you have a large org, try to write some of the queries and see yourself like, okay, are you able to query? Because the moment you have like large volume of data in those orgs, and when you write query, your query will time out. And you'll learn hard way that there are ways to optimize it by making data model or fundamental changes. That is, by making sure that you're not using too many ands here. Like if you can combine them, right, you should. And also by avoiding nulls, like here so many null statements are here, right, avoid them if you can. Like for example here, right, I'm not using any null statements, I'm just using score greater than 0. That automatically takes care of like even nulls, so I don't need to put that actual nulls in my queries, right? So something to consider. Let's see. Thanks for some suggestion around how to present the content, Melissa. Really appreciate. Yeah, so the difference between bulk 200 records, chunk query, yeah. If you need to perform DML on more than, say, when you're cleaning old records, are you forced to create a batch? Of course, yes, you are forced to. Yeah, you are forced to create a batch or put it in ACE, like queuable. Queuables are the other way to work with the large chunks of volume where you can queue, like you can query for, let's say, 10 record, like, sorry, say you have like million rows to query, you can chunk them within some different queuable classes. I can keep running. We already have some patterns. If you go to LDB recipes, you will see a code that demonstrates how to process a large amount of records in serial chunks using queuables. So you should actually look into that. This will help you to understand how to use one of those things. Okay, cool. Now coming back to writing reusable code. No quick ways without committing classes to production though. No. The quick way is don't use Apex. I mean, they use, so the question here is like, is there a no way? I mean, they don't want to deploy Apex, but still want to clean certain records and things like that. I mean, don't use Apex, use something else like data loader or, Salesforce CLI to run some scripts. Things like that, or use a middleware tool to do your job. Don't use Apex. As I said, don't overuse Apex for something that it's not designed for. It's designed for business automation on transactions. Okay. All right. Now writing reusable Apex code. Okay. So how many of you have written triggers? Lots of you, right? I mean, if your org does not have one even single trigger, I'll be surprised. Everyone has triggers in their org. So one of the best practices of triggers is make sure that you adopt a trigger framework when writing triggers. That'll ensure you're writing one trigger per object. And the framework whatever framework you choose, have some flexibility, like you can control, the order of execution of your logic, a bypass, some of trigger frameworks has a bypass logic, adopt a trigger handling, error handling patterns, right? And we show some of these actually in our Apex recipes. So if you actually go to um, trigger recipes, you will see we have a trigger handler. We have this whole framework called trigger handler, which implements a lot of things for you. And then we show examples of how to like sort of use them. Basically you will create a class, like instead of having everything in the trigger, in this case, like account trigger, right? Um, so in this account trigger, I'm just calling that account handler class, you know. So this framework is for just invoking it. Now, if you want to like use custom metadata to handle your trigger transaction logics, then use metadata trigger handler. So these are two different patterns. Now there are hundreds of patterns. Don't reinvent the wheel. There are hundreds of patterns that community has created. Find a one that suits your team, your requirements, simple to understand, and make sure you have like one trigger per object. Um, ensure that you can control the logic, and ensure it has an error handling framework. Now, there are also ISVs out there that can help you out. There are some ISVs which provide these error handlers and things like that. Always good to have, because at the end, right, when you have too much code in your org, monitoring those errors, resolving them becomes critical to the success of the business. So, question here. Here is a different trigger framework. Yeah, thanks, Amit, for sharing. All right. The next thing is writing maintainable code. And this is like, I would say, maybe the most important part. Okay. So imagine you're working on a team, okay, of 4 or 5 developers, and everybody has their own style of like writing logics. Like, for example, somebody was like, used to loops like this. Somebody is like, okay, I like this. Somebody is like, oh, wait, I don't write loops like that. I kind of don't want to, I kind of like this kind of style, like this, right? I've seen this. What happens if everyone starts to following their own conventions? Well, let's say, after 2 years of your project, some of you got promoted, some of you got good other offers, moved on. Somebody else is actually troubleshooting your code, and they don't know because it's not consistent. They're finding it harder. Somebody's just, sort of formatting the code. So what is writing maintainable code? That means it should be very easy to maintain going forward. That means everyone has to follow a consistent conventions, naming conventions. I'll talk about how to format your code, formatting conventions, um, code review process, writing proper unit tests, things like that, so that it's maintainable. Going forward, anybody can take a look at the code, know, okay, this is the style, um, have continuous integration, so that if somebody wants to fix something, they fix it and the continuous integration servers run and validate. So you have an automated way of validating. So you know that, okay, my change is not going to break anything else somewhere, in other part of the logic, right? So how to do that? So writing maintainable code is, defining and adopting a uniform naming convention. Work with your architects, work with your COE to define those naming conventions, sort of socialize them within your organization. It's going to be a cultural change. Come together and make sure that everyone agrees to it, agrees to the convention, stick to it, have code review process where you catch people who are going, sort of in a different path. Avoid hard coding IDs. Again, PMD to scan for code vulnerability, implementing CI/CD, for breaking changes, discovering changes, consistent formatting with prettier, right? Somebody, like, for example, look at our code here, right? This is all prettified. Like I can say, oh, this is pretty, I use like an extension called prettier. So you can see how we set up in this project, like I can Even if I like say, let's say I go ahead and do one of my if loops, I remove something like this, right? Try to save it. And let's say maybe this is a bad example. Maybe I don't have the prettier. Okay, I might not have the prettier, right? This, you see, so I have PMD. It tells me, oh no, no, this is wrong. Don't do this way. Your if and statement without curly braces is not allowed, right? Um, so use PMD to write your own styling and rules and things like that, right? Also, if I sort of it wouldn't disappear, right? So yeah, so use Apex PMD, use prettier to format it, right? Like let's say I try to like, do some misformatting here, and I can just reformat using prettier. You see, it automatically reformatted for me. So use prettier. So here we have a prettier here. You can install. So if you look at here, go here and look at package.json, we might have prettier. So I have a prettier setup. And there's if you go to our developer.salesforce.com, you'll find how we set up all these things. In fact, if you create a project scaffold today in Salesforce, it'll automatically bring the prettier. So you do an npm install, so your project has prettier automatically installed, so that everybody can come to a convention and just follow that. It uses Apex prettier here. Like prettier is for other languages as well, but yeah, consistent formatting. Documenting using Apex docs. So in this case, we had to write code so that every developer can understand them, right? There's a built-in documentation. Now, this is optional. If you are building some kind of a library on an SDK or an open source project, then it makes sense to like sort of document them. And if you are building some kind of a reusable utility that you want everyone to sort of adopt to, then you use this, right? Document them. Apex docs can actually help. Go look at Apex docs. We use them as well in this Apex recipes. And then finally, meaningful test. That means you are writing test data factory to create reusable data. Now, there's two things when you are testing. One is unit testing, one is integration testing. What we do today, like what we show in our examples here, is more of integration test, I would say. It's not a unit test. A unit test is something like this, a mocking. So it actually uses a mocking. It never uses an actual database call. So you could use like stubs and mocks to, there's a stub provider interface that we provide. But there are other libraries that are built on top of that stub, so that you can easily do unit testing. So do both unit testing and integration testing, write meaningful negative tests. That's very, very important. Lots of things here. Code review checklist. Thanks for sharing. Also, I'll share some resources where I have some code checked. Avoid you never hard code IDs, correct? Of course, yeah. Never hard code IDs. Yep. I mean, sometimes you might have to, maybe when you're like deviate, like let's say you want some, your code to run, but in Apex, in test context, maybe you want to provide some hard coded IDs so to satisfy test. Now, Salesforce is not like, Apex is not 100% perfect in terms of unit testing. So sometimes you just have to mock certain things. Those cases, it's okay to use hard coded IDs, but definitely not in your code. Especially I've seen people using record type IDs, hard coded in code. In my past uh, companies that I've worked for, I've seen code where people used to like use custom labels and store these hard coded IDs. That's even more crazy because once you translate them, then it becomes more good. Any recommendation for mocking libraries? That's a good question. We have built one. You can look at one of them. I think in the Apex recipes, I think it's called. Let's see. If you go to testing recipes, we have this stub recipes. I think stub. You can look at this stub I think stubbing recipes. Yeah, stubbing recipes. You can go look at this. So uh, yeah, so where I think we try to build our own sort of think it's called, let me see. Stub example class. Yeah, stub example class. I don't know if it is like a pattern. It was written by my colleague, but let me find that. So let's see. This one, right? Yeah, it's built a nice pattern. You can see how to build like stubs, do your own stubs by um, stub example. Yeah. I don't think it's a pattern, honestly. I think it's just more of a individual way of showing how to use stubs with an example. But I think one of the libraries that I had used in the past is I think it's called Superstar. Yeah, I used this. I used Kevin Superstar. It was great. That works great actually. The Superstar, where you can say, which class you want to stub, and then when your mocking method is true, what parameters, what it should return to, etc. Also, I've used financial forces stub actually. Financial. Yeah, we used financial forces, a couple of libraries out there. Let's see if they have. Apex mocks, yeah, this one. I've used this. Yeah, this is also an open source project, so I've used this. It also makes very easy stubbing your thing. Yeah, you can stub things. You need Java for this actually to generate all those mock classes, etc. And there are libraries. I mean, there are the you if you actually search over the internet, you'll find so many libraries. So I don't want to promote someone, there's so many libraries out there, but don't reinvent the wheel. There are already lots of. I think one of the other libraries that I saw was called AMOS. Yeah, this one. This was really nice. This is another one that I really love. Or it's pretty simple to use actually, you know. And most of them you will see following a builder pattern. This is called builder pattern, where you will basically say, okay, when this method, then return this, Also, when the method is this, return this. So it configures these two methods with what should return. So basically, a mock is something where you say, okay, if for this class, for this method, return this. That's all, right? So that's all it says. Yeah, I love this library actually. Yeah, I've used this in my actual projects. It's a pretty based on fluent pattern or builder pattern. Yeah. Yeah. Nice documentation on how to use stubs. So yeah, I mean, if you are like not trying to re-engineer from the scratch, you can just install these default classes. I think it has like a bunch of 4 or 5 classes. Even if you are like curious, go under the hood and look at it, look at how the author has built these libraries. It's always interesting to look at some of the open source work that people do put in a lot of effort. It's like maybe 4,000 5,000 lines classes, but yeah, I mean, simple to use at the end of the day, abstracts away all the complexity for you. Okay, any questions so far? Yep, thank you. Yeah. Is there a way to read debug logs in VS Code just like debug console? Yeah, we've done some videos around how to do it. Um, yeah, there are ways to do that. Just check out like our YouTube channel. You'll find lots of videos around how to use Apex Replay Debugger, how to like stream logs onto your local machine and things like that. on our YouTube channel. It's called Salesforce Developers. Okay, writing maintainable code. So these are some of things that I use. See if you find it helpful. Salesforce extension is what I use. Interactive debugger is something that I use for interactive debugging. And then I use Prettier, Apex PMD, Apex Docs, Apex Log Analyzer from Financial Force. So all of these things I use it. Actually, it's pretty easy. If you're using VS Code, you can actually go to you can just say Salesforce extension pack expanded. Salesforce extension pack expanded. And there you can actually just install that. It'll install most of the things that you need, like ESLint, Prettier, Apex PMD, Apex Log Analyzer, everything. Okay. And Apex Docs is NPM, this one, if you're writing Apex Docs. Okay. Again, all of these is opinionated, feel free to use other community contributor tools. This some of them I use. So nothing against, anybody who is like building any other trigger frameworks and things like that. And then finally, I have some references for you, like Apex recipes is one point. I'm actually looking for some feedback on Apex recipes now that I will be sort of working on a few more recipes for beginners, basically for beginners who are trying to learn Apex now. And then, this is the Trailhead module that I recommend for coding conventions, like around Apex. This is a very neat little module that talks about coding conventions. And finally, Apex best practices, where it talks about some of the Apex best practices that you should consider. All right. With that, Amit, let me take some few more last chats, and I think, yeah, Code Live sessions. Absolutely, check out Code Live sessions. Can you type mock libraries which you browsed here in the session? Definitely. Let's type it. So the mock libraries that I browsed, let's put it in the chat. So this is Superstar from, let me say to everyone in the middle. This is Superstar from Kevin. This is Financial Forces, Apex mock libraries from Financial Force, but I think it's more gone to open source now. It's called Apex Enterprise Patterns. And then finally, Amos. Okay, cool. From Bob. There you go. All right. I think we are end of the session here.